Students, now we are going to find electric potential due to dipole. Here is a dipole minus q plus q. Due to this dipole, we are going to find out electric potential at axial point. This is the axis. Which is the axis? The line joining minus q plus q of the dipole. Dipole length is 2a, a plus a, 2a. On this axis from center at r distance point n is there where we have to find potential. So due to this dipole at the axial point n, we are going to find out potential, electric potential. Because the dipole will establish electric field around it. In that electric field at every point, electric field intensity E will be there and electric potential V will be there. So we are going to find out electric potential V. Now first due to minus q charge, their potential how much? I am writing, that is I am calling V1. That is minus q, so minus 1 by 4 plus 1 0 q by distance. What is the distance? Minus q to point n. Center to point n, distance is r. Minus q to point n, distance will be a plus r. So r plus a. So distance we should write below. Because you know formula for potential due to point charge is 1 by 4 plus 1 0, 1 by 4 pi epsilon 0 q by distance. Similarly, potential due to plus q charge there is V2. It is V2 is equal to 1 by 4 pi epsilon 0 q by distance of the point from plus q to that point distance. From center to that point distance is r and this distance is a. So from plus q to their distance is r minus a. So distance is r minus a. Then total potential at point n, how much? Means what? V equal to V1 plus V2. So V equal to 1 by 4 plus 0 q into minus 1 by r plus a plus 1 by r minus a. Because the common terms are taken outside. Then q by 4 plus 1 0. If you take LCM, r plus a into r minus a, r square minus a square. Here minus of r plus a, here r plus a. So r will get cancelled. Q by 4 plus 1 0, 2a by r minus a square, r square minus a square. And q into 2a, there is a dipole moment p, so p by 4 plus 1 0 into r square minus a square. If r is very greater than a, then a square you can ignore. Then the formula for potential at axial point will become p by 4 plus 1 0 r square. Okay. Now this time we are going to find out electric potential due to dipole only at a point which is present on bisector line. Bisector line पर रहने वाला point के पास potential find करने जा रहे हैं due to dipole. Now for that bisector line I have drawn from center point at r distance. I have chosen on point n at r distance from center of the dipole. This is a dipole minus q plus q, and from center O perpendicular distance. Perpendicular is drawn, which is called bisector. On that bisector from center at r distance point n is there, at where we have to find potential due to complete dipole. So due to minus q charge, there I am finding potential. Further we need distance from minus q. So this distance is a, this is r. By using Pythagoras law, this will become my root of r square plus a square. So distance also we know, charge we know, at point we have to find potential V1. So V1 is minus q by 4 pi epsilon 0 into distance. Distance how much? This. Similarly, due to positive charge there at point n, what is the potential? Positive charge, plus q by 4 pi epsilon 0 root of same thing. Same thing. Both answers are same, equal, but one is positive, one is negative. So total potential if you find, you will get 0. So total potential at point n is 0. Not only point n, on that bisector surface, perpendicular bisector surface, not only line surface, if you imagine like this, surface, on that surface at every point, potential will become 0 due to dipole. Because every point on that surface, every point will be at equidistance from minus q and plus q. Minus q से plus q से equidistance for the point. So at this point, due to minus q negative potential, due to plus q positive potential, both will get cancelled. Potential will become 0 at every point on this surface. So that's why this surface is called equipotential surface. Because at every point, potential is same. Of course, it is 0. That is called equipotential surface. If so, in case of dipole, equipotential surface कैसा रहेगा? Perpendicular bisector surface. Means what? Center point के द्वारा जाते हुए dipole के axis को perpendicular रहता. That is called, because this question has many times it has come in examination. Show the equipotential surface in case of electric dipole. Means what? Perpendicular bisector surface. Means what? Dipole के axis को perpendicular रह के center के द्वारा जाने वाला perpendicular surface is equipotential surface. Now is for one more question I have taken. Suppose a surface पर नीचे r distance पर एक point है A, ऊपर r distance पर और एक point है B. So यहाँ से यह एक charge मान ले BQ that I am going to take to point B. how much work I should do. Means what? Same equivalent surface पर 2 points A and B. So A से B को Q चार्ज को चलाना, ले जाना, कितना वर्क करना पड़ेगा. So equivalent surface का प्रॉपर्टी क्या? So work done anywhere, work done if you want to displace any point charge, कोई भी point charge को एक point से दूसरे point को displace करने में कितना वर्क होता, Q into potential difference V2 minus V1. So the charge which you are displacing is big Q. So in the place of Q, big Q. And V2 final point is B because I am displacing Q from A to B. So final potential 0 and initial potential A, where potential A is again 0. So that is why Q into 0, that is equal to 0. Means what? No work will be done in displacing any charge from one point to other point on this equivalential surface. Next, now due to dipole only, we have to find electric potential this time at different point, neither on axis of the dipole nor on perpendicular bisector. It is located at distance r from center, and that distance is making angle theta. So this is dipole axis minus Q plus Q. Its length is A plus A 2A. Center point is O. From center point, the end point is at r distance, and the distance is making angle theta with the axis of the dipole. So due to this dipole, at that point we have to find potential. First, these two I am joining, minus Q to N plus Q to N I am joining. That is a construction, and I am calling this distance as R2, and this distance as, this is R2, and this is R1. This distance I called R1, this distance as R2. Then minus Q के कारण यहाँ potential कितना? So कितना? Minus Q के कारण potential V1 is equal to minus Q by 4 pi epsilon 0 1 by R2, because distance is R2. From charge to that point, distance is R2. So potential there is V1 equal to minus Q by 4 pi epsilon 0 1 by R2. Similarly, plus Q के कारण वहाँ potential कितना? So plus Q के कारण potential V2, that is equal to Q by 4 pi epsilon 0 1 by R2, because plus Q से R2 distance, plus Q से R1 distance पर है. So it is at R1 distance, that is why potential V2 is Q by 4 pi epsilon 0, charge Q by 4 pi epsilon 0 into 1 by distance R1. So इस तरह at point N we got potential V1 and potential V2 due to minus Q charge and plus Q charge. Now total potential V, how much? Means what? V1 plus V2. Means what? Minus Q by 4 pi epsilon 0 1 by R2 plus Q by 4 pi epsilon 0 1 by R1. Now taken common, Q by 4 pi epsilon 0, then minus 1 by R2 plus 1 by R1. That means Q by 4 pi epsilon 0 into 1 by R1 minus 1 by R2. So in this way, total potential at point N we got. But in this R1, R2, we imagined R1, R2 distances. So we have to change the answer from R1, R2 to R and theta. To change that one, first I am considering this triangle. Which triangle? In which R side is there, R1 side is there, A side is there, and here angle is theta. One is R side, second one is A side, third is R1 side, and here angle is theta. Which to which side oppositely angle is theta? Theta का opposite side is R1. Theta का opposite side is in a triangle R1 is. Then cosine law क्या? Theta का opposite side है ना, उसका square R1 square must be equal to R square plus A square minus 2 RA cos theta. So R2 square, this is R2 square out of R1 square actually. This distance is R1 square, R1. So R1 square must be equal to R square plus A square minus 2 RA cos theta. This is called cosine law. So means what? Theta का opposite जो भी side है, that side square is equal to this side square plus this side square minus 2 into this side into that side into cos of the angle. So R1 square is equal to R square plus A square minus 2 RA cos theta. This is called cosine law. In any triangle you can apply. So this is R square. A we are ignoring here. A means what? Half length of the dipole we can ignore because R is very large. If you ignore A square, but here A you cannot ignore, only A square you can ignore. So R square minus 2 RA cos theta. Then R square is taken common. R square into 1 minus 2A by R cos theta. Then R1. Then R1 square का आंसर ये था. R1 चाहे तो स्क्वायर रूट कर दोनों साइड. So स्क्वायर रूट करते स्क्वायर चले गया. R यह स्क्वायर रूट आएगा 1 by 2. नेक्स्ट रेसिप्रोकल करना. R1 है 1 by R1. 1 by R. R रेसिप्रोकल 1 by R. So 1 minus 2A by R cos theta reciprocal 1 minus 2A cos theta by R into whole power minus half because of reciprocating whole equation. R1 का reciprocal 1 by R1. R का reciprocal 1 by R. इसका reciprocal power half था power minus half. Then binomial theorem है. So इसे expand करते क्या था? First term will come as such, 1 is 1 only, minus second term power into second term. Power कितना? Minus half. Minus half into second term 2a by r cos theta. 2a by r cos theta. Then 2 got cancelled, minus minus plus. So 1 by r into 1 plus a by r cos theta. Then expand करने से 1 by r1 is equal to 1 by r1 है, इधर 1 by r1 है, is equal to 1 by r, expand कर 1 by r into 1 by r plus a by r square cos theta. This is equation 1. No, that means we have found 1 by r1 which is needed here. 1 by r1 we found. Now we are finding 1 by r2. 1 by r2. R2 means what? This here, this side. Here angle is how much? This angle. If this is theta angle, this will be 180 minus theta. 180 minus theta. And this side is R2, this side is A, this side is R. So here also triangle. One side is R, one side is A, one side is R2. So ये angle कितना? 180 minus theta. So angle का opposite side R2. So R2 square must be equal to A square plus R square minus 2RA cos 180 minus theta. So that only I wrote here. So then after simplification we get in the same equation we can do changes. What is that? In the place of theta we can write 180 minus theta. Then 1 by r2 will be equal to 1 by r2 will be equal to 1 by r plus a by r square into cos 180 theta. Cos 180 theta minus a cos minus cos theta. Minus cos theta. So 1 by r2 is equal to this. Next V answer we got till q by 4 by 0 1 by r1 minus 1 by r2. 1 by r1 answer we got here. 1 by r1 answer we got here. 1 by r plus a by r square cos theta. So 1 by r plus a by r square cos theta. And 1 by r2 answer here is there. Before that minus is there. So minus 1 by r plus a by r square cos theta. So 1 by r got cancelled. Then q into 2a cos a by r square cos theta plus a by r square cos theta. 2a by r square cos theta. So q into 4 pi epsilon 0 is there. 4 pi epsilon 0. So that equal to q into 2a become p, dipole moment, cos theta is there. And 2a into q become dipole moment p, cos theta is there. So p by 4 pi epsilon 0 cos theta by r square. That is p into, we can write p into cos theta, we can write as p into 1 into cos theta by 4 pi epsilon 0 r square. And this we can write as dot product. Cos theta is no dot product. Instead of v is equal to p bar dot. This is one vector. Here this is one magnitude or a vector को unit vector बोलते हैं r cap. So p bar dot r cap by r square and 4 pi epsilon 0. So this is the answer. Because if you expand this, you will get what? See, p bar का magnitude p, r cap का magnitude 1 because it is unit vector, and angle which should come cos theta in case of dot product means what? 1 by 4 pi epsilon 0 r square. So same what we got. That is why we can write in compact form like this. So we found potential at oblique point, not on axial line, not on perpendicular sector, at different point on the, in case of dipole. So potential due to dipole at one point we found.